Welcome back to the Smart Tips channel. Today we will explore what a small AA battery, which seems useless, can actually do. Let's get started. Step 1. Attach the battery to the drill head. The process begins with preparing a battery, a common energy source in everyday life. Batteries are usually used to power small devices, but in this DIY idea, it is attached to the drill head. The drill is a mechanical tool, and when combined with the battery, it symbolizes the connection between energy and tools. This is the starting step, representing the introduction of energy into the system, like starting up a creative machine. Step 2. Turn on the drill and place a saw on the battery head. When the drill is turned on, the saw blade is placed against the battery head. This action simulates the process of cutting open the outer shell of the battery to reach the inner core. The battery casing is like armor, protecting the energy inside. In this simulation, cutting the casing represents exploration. Step 3. Use pliers to remove the battery core. After the casing is assumed to be cut, pliers are used to pull out the battery core. The core is the important part, containing activated carbon and compounds capable of conducting electricity. This is the main material, playing a central role in the simulated creation process. Removing the core is like taking out the heart of the energy source, preparing for the next transformation. Step 4. Peel off the protective layer and put the carbon into a container. The pliers continue to peel off the protective layer of the battery core, revealing the carbon inside. This carbon is placed into a container. Battery carbon has conductive properties and is used in many scientific experiments. In this idea, it becomes the main material for the next steps, like extracting raw resources to prepare for production. This is an important step, because from raw material we will create something with practical value. Step 5. Use a torch to dry the carbon. The extracted carbon needs to be processed. A torch is used to dry the carbon. Drying makes the carbon more stable, easier to use, and better at conducting electricity. This is an important preparation step, like refining raw material before production. Dry carbon can also be ground into fine powder, making it convenient for later use. Step 6. Take a plastic water bottle and drill a hole in the middle next. We prepare a plastic water bottle, a common household item. A drill is used to make a hole in the middle of the bottle. This hole will be where a motorcycle valve is installed. The plastic bottle acts as a container, and the drilled hole is the connection point, turning the bottle into part of the DIY system. This step shows creativity in recycling, transforming a discarded bottle into a useful component. Step 7. Pour carbon powder into the plastic bottle. Carbon powder is poured into the bottle. The powder acts as a conductor and filler, creating a simulated environment for electricity to pass through. This step turns the plastic bottle into an energy container, where carbon powder functions as the medium for transmitting electricity. It illustrates how raw material can be transformed into a functional component in the system. Step 8. Install a motorcycle valve into the bottle. A motorcycle valve is fitted into the hole in the bottle, becoming a connector. This is a creative step where a familiar mechanical part is repurposed to create a simulated welding circuit. Normally, the valve is used to pump air, but in this model, it becomes the connection point between the carbon-filled bottle and the electrical wire. This demonstrates the DIY spirit, repurposing everyday items to serve new functions, creating solutions from seemingly unrelated things. Step 9. Connect a wire to the valve and the battery core to form a welding tip. A wire is connected to the valve and the battery core. Once connected, we imagine that energy from the battery flows through the wire into the carbon-filled bottle and forms a welding tip. This simulates the principle. Electricity passes through conductive material, generating heat, and that heat is used for welding. This step shows the combination of components. The battery provides energy, the wire transmits it, the carbon powder conducts it, and the valve acts as the connector. Step 10. Weld a screw head. With this simulated welding tip, the process of welding a screw head is demonstrated. When the tip touches the screw, we imagine heat being generated, melting the metal surface, and bonding the parts together. This step best illustrates the DIY idea, turning simple materials into a tool capable of performing a complex task. It also demonstrates the basic principle of electric welding, using heat to join metals. Step 11. A drill case with a hole. Next, we test how to fix a plastic drill case with a hole. This is a common real-life situation. A plastic container gets damaged and can no longer be used. DIY here provides a creative solution to repair it instead of throwing it away. This shows that DIY is not only about creating new things, but also about extending the life of old items. Step 12. Mix. Baking soda with carbon in the bottle. Baking soda is mixed with carbon powder in the bottle, creating a mixture that both fills gaps and adds strength. Baking soda is a household substance, and when combined with glue, it produces a strong chemical reaction. Carbon in the mixture increases hardness and durability. This is the combination of chemistry and mechanics, producing an effective repair solution. Step 13. Put the mixture into the hole and add superglue 502. The mixture is placed into the hole in the plastic case, and a few drops of superglue 502 are added. Superglue is extremely adhesive, and when combined with baking soda, it creates a chemical reaction that forms a solid material, tightly bonding to the plastic surface. As a result, the hole is sealed, and the plastic case is restored and reusable. This is a popular DIY trick, showing how simple materials can solve practical problems. Conclusion: throughout the process, we have seen creativity in repurposing familiar materials to create new applications. From the battery, drill, plastic bottle, motorcycle valve, wire, to baking soda and superglue, all were cleverly combined to simulate the principles of welding and plastic repair. This is proof of the DIY spirit, constantly experimenting, constantly innovating, and always finding new ways to solve problems. Thank you for watching the video. Goodbye and see you next time.